Hi there, and welcome back to another Papetti Math YouTube video tutorial, where I'm going to be teaching you, yes, you, Algebra 1. And in this video, we're going to be looking at exercise number 5, where we're going to be graphing our first exponential decay function. And we know that it's going to be decay because the number inside the parentheses, the growth factor or decay factor, is less than 1. So we're going to be multiplying by half each time. So it's going to be getting half as big, which means it's going to be decaying and not growing. So it says on the same set of axes above as exercise number 4, we're going to graph the function 1/2 x. So let's choose red. And we know from this part that anything in the form of y equals b to the x has a y-intercept of 1. And then half as big as 1 is 1/2. Half of that is 1/4. Half of that is 1/8 and 1/16, and so on. Now moving backwards, if we're multiplying by 1/2 going this way, we're dividing by 1/2 going this way. Or the same thing as dividing by 1/2 is doubling. So if we have an answer here of 1, we had to have 2 there because half of 2 would have given us 1 as we read it from left to right. Half of 4 would have given us 2. Half of 8 would have given us that 4. And finally, half of 16 would have given us that 8 value right there. So this is 1/2 to the x, and again, you can put this in your calculators and pull up the table of values, and you'll see that you'll have a smooth curve. That's quite the opposite of the exponential growth function we graphed in exercise number 4. But yeah, this is y equals 1/2 to the x, and this is an exponential decay function because it's going to decay at a rate of 1/2. So describe the domain and the range. So our domain here is, well, that's going to go up and to the left forever. It's going to go down and to the right forever. So it's going to go to the right forever. I won't say down forever. But so our domain is going to be all real numbers, or from negative infinity to positive infinity in interval notation. Our range, on the other hand, we talked about an asymptote in the exercise above, and this will keep going half as big, half as big, half as big, half as big. It will never approach 0. So our range is going to be from 0 to infinity. And we're not going to include 0 because it will actually never reach 0, but it will approach it forever. Get closer and closer forever, but never actually touch 0. So our range is going to be from 0 to infinity because the range obviously goes up forever. Okay, how does the graph compare to the graph of y equals 2 to the x? Well, we could say that it is a reflection over the y-axis. That would be one observation you could make among many others. You could say that they're opposites. You could say that one's increasing by 2, one's increasing by 1/2, one's being multiplied by 2, one's being divided by 2. You could use anything you want. But the basic observation is that it is a reflection over the y-axis. As you can see, one is reflected right over the other in the y-axis. Now, if this video is helpful in graphing an exponential decay function, give it a thumbs up, and you're now ready for exercise number 6. Click on the link in the video right now. Thank you for watching.